Good morning, everyone. Good morning. Good morning to all of you. Am I audible? Very good morning, Sai. Very good morning. So, by the last class, we have discussed in class up to which part? Good morning, Uma. Good morning, Madhu, Anuradha. Very good morning, Subarao. Good morning, Fayazoon. Atomic radius. Okay, we have studied atomic radius. Before starting it, in the last test, any questions you want to ask in the test? In the test, you want to ask any question from 150 or 160 onwards. In any option, you want to ask any point. Bolo, any point? One key change, yes. 2 and 4 both correct. Good morning, Model Hari. Ramcharan, good morning. Good morning, beta Kirtani, Victor Babu, good morning. Sambhavi, good morning. Meena D, yes, good morning. Any question in the paper, any option you want to ask in track 2, periodic table 159 onwards? Paper uploaded क्या है? Ravi, paper uploaded? No. There. Okay. Anyone want to ask any question? Anyone want to ask? No. If they ask, I will tell. Any question in the paper? Bitra, okay, fine. Up to last lecture, we have discussed in the periodic table chapter. We have discussed all these things. Yes. All this part done, but still remember, students, you have to read it. Make this habit of reading NCERT. Definitely you will get more points. Definitely. Everything you cannot write in notes. Take, mark good lines in NCERT, keeping in mind you will read notes, recall them 5 times before going through ahead. And then in NCERT, you will underline some important lines. Those lines also you have to learn, write properly, learn and recall them. ठीक है, ये हो गया था. This we have done. Still go through that part where given non-metals, metals, metalloids, all this is given here, highlighted in colors. Then this part we have discussed generally, not discussing the highly reactive nature or low ionization enthalpy. These terms we have not discussed yet. Why? Because with the chapter when we do, then these terms you can relate faster. But still read that portion, why inert gases are least reactive or almost not reactive. Transuranium elements, problem, this is done. Still read that paragraph, metals, non-metals and metalloids. Getting it? Still read the story given, how much percentage are for metals, how many metalloids, all this still read, which are liquids at room temperature, and which metals. Read that portion, information based. Then we have discussed after that, which term? Z effective. Yes, Z effective we have discussed. Recall it, what's the meaning of Z effective? What's the meaning of Z effective? Check your notes, turn the page, read that one. Z effective means, what is the periodic trend that is useful for atomic radius understanding? then useful for ionization enthalpy understanding. Done, reading done. Z effective. Other students also. Z effective is net or wait. Z effective is final or net positive charge experienced by the experienced by the valence electron after considering repulsions due to inner shell electrons. This nucleus is attracting the valence electron, and simultaneously this electron is getting the shielding effect and repulsions of the inner shell electrons. So the net attractive force on this valence electron is termed as Z effective, which is equal to actual nuclear charge minus screening constant or shielding constant or Slater's constant. Okay. Now along the period trend we have discussed. Along the period, Z effective increases. Take why Z effective increases? Because in the same shell, because along the period shell remains same. In the same shell electrons keep on adding. When in the same shell electrons are adding, the shielding effect will be almost similar because inner shell electrons remains unchanged. The shielding effect is not increasing, but continuously the nuclear charge goes on increasing as we move across the period. Therefore, along the period, Z effective overall increases because inner shell electrons are not increased and shielding effect is same. Second, along the group, if you observe, along the group, whenever we move across the group, electron moves to the new shell. Along the group, every time new shell is added. When new shell is added means inner core electrons or inner shell electrons are more coming with next moving with the shell. First here, then second inner shell 1, then third inner shell 1 and 2, more electrons in between, more shielding effects. That is why Z effective is not increasing, almost constant, because distance away from the nucleus, more shells are adding, more shielding effect is there. So what is the trend across the group? Z effective almost constant or very slight increase is there. ठीक है? Yeah, Psi 45, yes, there will be space exam this week. Up to this point, clear? Z effective. Then we have discussed about the shielding intensity order within the same shell, maximum by s orbital, then p, then d, and then f. D and f, more diffused orbitals, poor shielding effects. More is the poor shielding effect, more is the Z effective. Clear? I'm just recalling, recall the last week part so that you can relate it easier in today's lecture. Then we have discussed atomic radius. 3 types we have discussed. Covalent. Achha, before that, any point you want to ask? Up to Z effective in the notes. Up to Z effective, you want to ask any point? Bolo. Till Z effective. Banod saying no, Sai saying no. Okay, other students. Any points up to Z effective? Srinivas saying no, blank, no, okay, yes, good one, good one. Nitini, no. Ashok Kumar, no. Uma Devi. Acha, screening effect. Screening effect, see. In the screening effect, Uma Devi, other students also, those who want to discuss screening effect. This electron, valence electron, is attracted by the nucleus. ठीक? Yes, attraction is there. That is why it is present within the atom. But the electron is not getting the full nuclear charge, which is equal to Z. Why? The inner electrons in the shells, they are blocking the some attractive force of this nucleus. These inner shell electrons are blocking the net or blocking the attractive force of the nucleus. Yes, that is why the electron, which is valence shell electron, it experiences some less attractive force, or it experiences some less positive charge of the nucleus due to these inner shell electrons. Due to these inner shell electrons, the repulsive force experienced by the valence electron, after considering repulsions or shielding effects due to inner shell electrons, this reduced nuclear charge from the nucleus is termed as the screening effect or shielding effect. This reduced nuclear charge from the nucleus on this valence electron due to the inner shell electrons present is termed as screening or shielding effect. They are blocking the attractive force of the nucleus. They are blocking attractive force of the nucleus. That is why the valence electron experiences less attractive force, which is Z minus sigma, that is Z effective. So shielding means what? The inner electrons or inner shell electrons, they are blocking or shielding the valence electron from getting the full attractive force of nucleus. So this is known as the shielding effect of the inner shell electrons or screening effect. Higher the screening effect, more will be the sigma factor and lesser will be the Z effective. Lesser is the sigma, lesser repulsions, lesser shielding, more will be the Z effective. So higher the Z effect or higher the sigma, less will be the Z effective. Now tell Uma, any other question, any other student up to Z effective? Up to Z effective, any other point? ठीक है, any other point anyone want to ask? Up to Z effective. From the last lecture notes, you want to ask any questions up to Z effective? ठीक है, Madhu saying no, okay, fine. Now, after this we have discussed atomic radius. ठीक, atomic radius we have discussed three types: covalent, metallic, and which one? Van der Waals. है ना? That we've discussed. Atomic radius में distance from the nucleus to the outermost shell where electrons are present of the order of which one? 1.2 angstrom. Then this example given: covalent radius, distance of the half of the internuclear distance between the two atoms involved in a covalent bond. Example, you can mark in your NCERT also: chlorine molecule bond distance is given 198. Half of this will be covalent radius. ठीक. Metallic radius definition is given. Then example, copper in solid state solid copper 256 picometer. Half of this bond distance will be metallic radius of copper. How they are measured? Underline that one. They are measured by which one? By X-ray techniques or spectroscopic methods. Then here, these lines we have discussed in notes. Atomic radius. After notes, in the notes we have written general trend. R, van der Waal, R, metallic, R, covalent. Done that one. Van der Waals is which one? Non-bonded state. Which example written? This type. These two atoms in neighboring molecule, yes, they are in van der Waal force of attraction. So among them, the distance half will be van der Waals radius. Van der Waal radius measured in which state? In solid state. Van der Waals radius, if you have not written, is measured in solid state. Then after the radius term, we have discussed about the factors and periodic trend. So periodic trend may in NCERT, if you have not marked, these are the lines given. Atomic radius decreases along the period. Yes, we have discussed in last class. Along the period, Z effective increases, atomic radius decreases generally. These are the reason given. You can read after the class, underline in NCERT also. It is along the period. Along the group, vertical column, increases regularly with atomic number. Reason, top to bottom, if you go, shells keep on increasing. Valence shell are very far away from the nucleus. Valence shell electron, and hence, finally, more shielding effect will be there. So all this part, reason for which one? The atomic radius top to bottom increases because shell value increases, inner shell electrons increasing, shielding effect is not playing any role. Shielding effect increases due to inner shell electrons, and finally atom size increases. Periodic trend clear? Any questions up to periodic trend? Then radii of noble gases should not be compared with covalent radii. Yes, Srinivasu, Alu, it is necessary to learn whatever in the questions we are getting. At least up to 30 remember, and remember group 18 elements. With the time you will learn more. Point is with using you will learn more. ठीक है भाई, यहाँ तक आया समझ में? Up to regular trend, up to periodic trend. Done. Then we have discussed examples. ठीक है, examples done. How many examples done? One was normal lithium, sodium, potassium. Other was beryllium, magnesium, calcium. I think that is also done. Then lithium till fluorine. These three examples done or not? These three examples. ठीक है, exceptions also done. This example done or not? Okay, that example also we have done. ठीक है. Then what about example of 3D series exception? 3D series में scandium, titanium, vanadium. This example, left to right, decreases, in the middle almost constant. Done. Which exceptions we have done? One was aluminium and gallium. Done. Then other one, 3D series, 4D, 5D series. Done that one. Here you have done example of which one? Zirconium, hafnium. In the notes mention it, group 4 to group 12. That works from group 4 to group 12. Group 4 to group 12. Not with scandium, deuterium, lanthanum. Because after the lanthanum, that lanthanide series is there, and then after filling of 4f electrons, which will come group number 4, which example also you can add in notes, group 5. क्या example है? Vanadium, niobium and tantalum. 3D, 4D, 5D. Yes, what's the reason for that? What's the reason for that? Due to lanthanide contraction. Recall fast. You have done or not lanthanide contraction? Lanthanide contraction. Yes, very good. Poor shielding effect of F electrons in 5D series. It increases Z effective, which leads to contraction in the size of 5D series elements. That is lanthanide contraction. Yes, आया याद? Lanthanide contraction. It works from where? Group 4 to group 12. Then other example was 3D series example. Up to this we have done, right? 3D series example we have done. Initially decreases almost up to chromium or Mn. Then from here almost similar trend, and then here increases. Because from this to this, Z effective dominates because of the more increased nuclear charge dominating, atomic radius less observed. Then here almost similar size of the atoms due to Z effective, and what was the reason written? Z effective and inter-electron. That example done or not? This example, inter-electronic repulsions, because the moment pairing will start in the orbitals, which factor we will say? Inter-electronic repulsions. Compensating each other. Compensate each other, and here inter-electronic repulsions. dominate over Z effective. Bolo. Up to this part, I think it was the last part. Huh? Till this part, we have discussed in notes. अब बताओ, till this point, anyone want to ask any question till this point? Because after this atomic radius exception, we will discuss about ionic radius. So till this point, if you have marked any question, till exceptions of atomic radius. Any point? No. Anyone go through, if you have, while learning it, you want to ask any theoretical discussion? Dikshit saying no. Other students, Sai also saying no. Other students, any point? No. Chasi saying no. Usha, Uma, other students, confirm till this point बिल्कुल clear है. ठीक है चलो. Next point is, okay, good, fine. Next point is in the atomic radius. Next term is ionic radius. So in ionic radius, the term is, we are discussing the ions. It may be cation or it may be anion. Loss of electron from neutral atom gives what? Cation. Gain of electron in the neutral atom gives anion. Now here, we will discuss that theory part also. So starting with the ionic radius now. In ionic radius, suppose any atom is there, A. Loss of electron is there and gain of electron is there. It becomes A minus, it becomes A plus. Opposite I have written. Loss of electron A plus and here A minus. Take. So we can compare their radius. They are derived from same element or same atom. A plus means less number of electrons and more number of protons. If more number of protons are there, or positive charge itself means attractive force more, means Z effective more. Take. A minus means what? Z effective less, because since electronic repulsions more. Since electronic repulsions are more. So what should be the correct order? The correct order should be anion will always be more than which one? Its neutral atom, because anion means more number of electrons, more electronic repulsions, more distance away from the nucleus, because more electronic repulsions means attraction force of the nucleus will be less with the outermost shell electron. Okay? So anion will always be more than its neutral atom. Cation, more positive charge, more Z effective, electrons more closely bound to the nucleus. More closely bound to the nucleus means less radius, Z effective. More, here Z effective less. This point clear? Cation always less than neutral atom, anion always more than its neutral atom. Compare their atomic radius. Write down the final order among them. Correct order of their ionic radius. In first one, the size of the ions. Higher the charge, negative, more will be the repulsion, more will be the ionic radius. Very good sign, very good. Second one, higher the positive charge, lesser will be the ionic radius. The neutral better than +1 better than +3. Similarly, next one. Next one. Now in next, it is a which case? In notes you can mention properly, isoelectronic species. In ionic species, isoelectronic species, the radius will be inversely proportional to Z. Out of these two, firstly, both contains 10 electrons. Isoelectronic, higher the negative charge, more repulsion, more ionic radius, or higher the Z atomic number, lesser is the ionic radius. So N is more Z it has less ionic radius, or whichever has more minus charge will be more ionic radius. Fifth, check your answers. Write down up to 10th. Done. Very good, Dikshit. Other students also keep on writing it. Anywhere want reason, you can mention it. Otherwise, already reason you know. Here, isoelectronic it is Fe2 plus 3 plus. Higher the positive charge, lesser the ionic radius. Lead will be more. Take the next one. Lesser the positive charge or more the positive charge, lesser the ionic radius. Al3 plus Mg2 plus, they are isoelectronic. Yes, higher the positive charge, less the ionic radius. Tenth, isoelectronic case. 10th is isoelectronic. Higher the negative charge, more is the repulsion, more will be. Sixth mein, I have not seen that one. Sixth mein, this is the order. 3, 1, 2. Correct sign. Done. 10th, isoelectronic species inversely proportional to Z, or higher the negative charge, more ionic radius, higher the positive charge, less ionic radius. Next one, isoelectronic. Take normal trend, top to bottom. In the periodic table, which is having the largest ionic radius in anion, monoanion, is I minus. This example only for material. NCERT is not discussing such example. 13th, hydride ion is undoubtedly looking like that it is from hydrogen, no doubt, but its ionic radius is even more than chloride or bromide comparable, less than I minus. So that is only used for module solving, that in H minus there are 2 electrons and 1 proton. That sudden twice the value of normal electron makes the electron cloud go much farther. But that is only by values we know. H minus is even more than Cl, F minus, or even more than Br minus, but comparable values also given. So general trend H minus more than these two, or even Br minus, but less than I minus. ठीक. This also important example, module solving example it is. Li plus is more than Mg2 plus. Reason is only how can we explain higher Z effective of 2 plus in Mg makes it overall less as compared to Li plus 1. That is the order for ionic radius. बताओ, in 15th, correct order. Correct order for ionic radius. Done 15th. Srinivas, Varsha, Dikshit, Sai. Other students think. Agnadu, okay, 3124. Kirtini, okay, answer is coming different now. Gola Ranganamma, 1324. Very good. Sambhavi, Batul, Dr. Madhu, good. Students, you can check the NCRT. I have given from NCRT this question. It is the NCRT question given. Here. This is the question given here. Among them, we know among them neutral definitely will be more than the ions here, plus charge, because they are not from the different period, they are from same period. Between magnesium and aluminium, we use which trend? Periodic trend. Mg more than Al. So first, third. Then between these two, they are isoelectronic species. Yes. Among the isoelectronic, we also know that aluminium plus 3 more positive, lesser the ionic radii. So final order should be 1, 3, 2, 4. Clear? Getting the answer, Agnadu? 1, 3, 2, 4. Then you can read this part after class. Cation is smaller than anion. Sorry, it's neutral atom, parent atom. Anion will be larger than its parent atom. Already we have discussed. Reasons given there. Increased repulsions are there. Example F minus 136. Atomic radius of fluorine is 64. Clear? Then we find some atoms, isoelectronic species. Same number of electrons are there. That is the meaning of isoelectronic species along with other terms given here. Then greater the positive charge, smaller will be the radius because higher will be the Z effective. Anion, greater the charge, more repulsions, larger will be the radius. Clear this term? So first term we have completed, which is radius, atomic as well as ionic. Take now. Next term is ionization enthalpy. In the notes, you can mark the definition. Energy required to remove electron from isolated gaseous in its ground state. The energy required means it is which one? Endothermic in nature. It is endothermic in nature. Right? In your NCRT, you can underline these lines. It is the representation in terms of reaction. X gaseous, loss of electron, it is X plus. Units given. Other term given, second ionization energy, it is a representation. Clear? Getting it parallelly? You can mark these lines also. Energy is always required to remove electrons from an atom. Hence, IE always positive. And second IE will always be more than first IE, which is first ionization enthalpy. Why? Because more the positive charge will come, more will be the attraction with the nucleus, more energy required. So always remember first IE, second IE, third IE. Successive values always increases, more and more endothermic in nature. Third always higher than the second one, and so on. ठीक है, NCRT line I'm just going through fast so that after class you will read it easily. That trend we will discuss also separately. Here you can mark in the periodic table. Highest value is for helium. Highest ionization enthalpy. Now next term is ionization enthalpy or ionization energy. To write down in the notes the definition, it is the energy required to remove most loosely bound electron, which is valence shell electron, from an isolated gaseous atom. From an isolated gaseous atom in its ground state. In its ground state. Energy required to remove valence shell electron or most loosely bound electron from an isolated gaseous atom in its ground state. What are the units? Kilojoules per mole or kilocalories per mole, or in the module you might get electron volt per atom. And represented as in this manner. First value or first term is IE1 or delta H1, also IE1. Any term can be given, we can understand. Take IE3. Ionization energy is endothermic. Energy is absorbed, right? Successive ionization energies Successive IE always more endothermic. That is IE1 always less than IE2, always less than IE3, always less than IE4, and so on. And so on. Because more is the positive charge coming, strongly electrons are bound to the nucleus, hence more and more energy given, irrespective of whatever electronic configuration is achieved by the element. Bolo, till this point, getting it? IE is always endothermic and becomes more and more endothermic by loss of electrons. Bolo, till this point clear? Now, which factors we can relate? First factor, as usual, Z effective. Z effective increases. Second, shielding factor. Shell size increases. First one, Z effective increases. IE will increase, more energy required to remove the electron. Sigma increases, repulsion and shielding factor increasing, less energy required. IE decreases. Shell number increases, distance of the electron from the nucleus increases as shell increases, less energy required to remove the electron. Then penetration power. Subshells which are closer to nucleus. Which are closer to nucleus are more attracted or penetrated towards nucleus. Hence, more penetration power. So which subshells are closer to the nucleus in their orbitals, electrons are more attracted by the nucleus, more attracted or more penetrated towards the nucleus. So penetration power means more closer or more attracted by the nucleus. That is the meaning of penetration power. So S, P, D, F. Which electrons are most closest? S, then P, then D, and then F. It is the correct penetration power order. ठीक है? Getting the meaning? So penetration power means the orbitals which are more closer, their electrons will be more tightly bound to the nucleus. Hence we will use which term? Penetration power. More attracted means more difficult to remove. So for a particular shell, SPDF, you can say for a particular shell, it is the order. Next point you can mention half filled and fully filled. Electronic configurations. Half filled and fully filled electronic configurations are highly stable. Hence IE will increase. Hence ionization energy increases. ठीक है? Then what is the periodicity, which is periodic trend? Periodicity. Along the period from left to right, and second along the group from top to bottom. Along the period, Z effective increases, IE also increases. Along the group, general trend decreases. Why? Since what is increasing? Shells are increasing and Z effective almost constant. Bolo, till this point getting it? Periodic trend along the period, along the group. IE generally increases. Why? Z effective increases, and along the group, top to bottom, Z effective almost constant, and shells keep on increasing, inner shells, inner core electrons increasing, distance of the electron from the nucleus increasing, less energy required to remove the electron. It is the meaning of periodicity. Other information you can mention in periodic table, highest ionization enthalpy value is for helium and lowest value is for cesium. Highest value is for helium and lowest is for cesium. Till this point clear, general trend written till this point, periodic trend in ionization enthalpy. Any questions you want to ask up to the periodic trend of IE? Up to this point. Confirm? ठीक है. So देखो अब periodic trend is one thing, but wherever we are not getting as per periodic trend, then we have to explain such examples. And that is the point you understand by this time, that one thing is periodicity. Important are those examples which are not following the periodic trend. As per the syllabus, we will focus on these with reasoning. So finally here, examples which are not following this trend is which one? Beryllium and boron. If you compare their ionization energy, beryllium and boron. Beryllium is which configuration? 2s2 and this is 2s2 2p1. Logically, out of these two, along the period, which should be more, i.e. boron, logically? Periodicity. But which observed to be more? It is beryllium. Logically, it should be more for boron, but the observation is beryllium, i.e. is more than boron. It can be explained by which way? It has only 2s2, fully filled configuration, 1s2, 2s2. It is 2s2 then 2p1. So here one such reason is half-filled configuration. Half-filled configuration, electronic configuration in beryllium. One thing which we can use for explanation. Sorry, half-filled nahi, fully filled. Forgot. It is fully filled. Yes. Fully filled electronic configuration. And important reason is here last electron in which it is 2s2. Here last electron in 2p. Which electrons are more tightly attracted or more penetrated towards nucleus? S orbital electrons. So important reason is penetration power. Rightly said by a student, Sai and Kirtini and Madhu. Yes, is penetration power of 2s electron is greater than 2p electron. Clear? So beryllium is exceptional behavior showing due to more penetration power of 2s electron, means it is more strongly attracted by the nucleus, difficult to be removed. ठीक? Beryllium and boron. Similar example, magnesium and aluminium. Left to right it should increase, but Mg is more, i.e. as compared to this one. Same reason. Fully filled configuration. Same reason, fully filled configuration, and important reason, penetration power. And penetration power. Clear? Up to this point clear? So today we are discussing only these two examples which are not following the regular trend. Then we will discuss about oxygen and nitrogen, and similarly we'll discuss about sulfur and phosphorus. Up to this part clear? So that you will read NCERT today up to IE. You will read that whole story. Examples more we'll do in the next class. Clear, students? Done? So atomic radius, revise properly, recall 3 to 5 times, then IE, read NCERT up completely for IE, and next class we'll do the completion of IE starting with the electron gain enthalpy. ठीक है? Okay students, तब तक के लिए बढ़िया से पढ़ाई करो, revise 3 to 5 times your notes, solve the module, PYQ solve before the test. 7 to 8 times you have revised your test syllabus. That is your target for the weekend. App will be informed. From wherever you are getting the information of the timetable, they will be informing you. Okay, Sai? ठीक है students, bye. Thank you.